Greetings everyone, I am Dr. Dipankar Das. Now I am going to discuss macromolecular or polymer chemistry with you. In this lecture, I will discuss the importance of polymer chemistry, the origin of polymer science and polymer industry, basic definition of polymer, macromolecule and nomenclature of polymer. At first, we will discuss why we should study or learn macromolecular or polymer chemistry as a basic science student or engineering student. We all know that chemistry is not only a scientific study that deals with the preparation of materials, properties of materials, and understanding their synthesis mechanism at molecular level or atomic level, but it also explains the mystery of the world around us and how to improve our quality of life. We also know that chemistry is called central science because it gives a foundation of understanding between the basic science and applied scientific disciplines at a fundamental level. When discussing polymer chemistry, we can see polymers are all around us. Polymer materials have a significant impact on our day-to-day life from morning to night, or you can say from toilet to bedroom. We are using polymers, we are with polymers. Naturally, to make sophisticated materials for our needs, knowing the preparation methods, properties, processing techniques, and application of polymer materials is required. Basic science students should know how polymers are made, how to characterize polymers, their properties, how to process them, and the possible application fields of the polymers. Engineering students, for example, chemical and industrial engineering students, must learn about different preparation methods, processing techniques, and properties of polymers. Polymers have good mechanical properties and are also used in construction area. Thus, civil and mechanical engineering students need to learn about the properties and the stability of the polymer. Polymers can act as insulator as well as conducting materials. As a result, electrical and electronics engineering students need to learn about polymers. Biotechnology or biomedical engineering students work with 3D bioprinting, macromolecules like proteins, RNA, DNA, which we often call polypeptides or polynucleotides. So they should study polymers or macromolecular chemistry. Many polymers are used in oil recovery, so petroleum engineering students should know the properties of polymers. Computers are made of with different kinds of polymers, right? So in contrast, students working with computational study or artificial intelligence need to know the structure and properties of macromolecules like proteins, DNA, RNA, and carbohydrate. As I have said, we use polymers from the toilet to the bedroom. If we see some examples, the role of polymers in our day-to-day life will be more clear to you and you will really be happy. Starting from the early morning, we use toilet papers made of with cellulose. We all know that cellulose is a natural polymer. We use soap or hand wash that contains carboxymethyl cellulose, polyethylene glycol, polyvinyl alcohol, or polyacrylic acid. So those are polymers. If we see, the hand wash container is prepared by polyethylene or polyethylene terephthalate. The towel is made of polyester or cellulose. Then we use toothpaste, right? Then we use toothpaste. Toothpaste contains xanthan gum, carrageenan, and carboxymethyl cellulose. So those are basically natural polymers. If we see the toothbrush handle made of polypropylene, polyethylene, the soft part of the toothbrush is natural rubber, which is a natural polymer. The bristle of the toothbrush is made of nylon, which is synthetic polymer. Then we take breakfast, right? Bread or rice item. Bread contains gluten as protein, carbohydrate, that is polysaccharides. Rice contains carbohydrate, that is also polysaccharide. It also contains amylase or starch. When you cook something, the cooking utensils handle, if you see the black color handles, is made of bakelite, that is phenolphormaldehyde, one synthetic polymer. Then we see tile in a wall clock, which is made of polystyrene or polyvinyl chloride or polyethylene. When you take mobile or laptop for our work, that has acrylonitrile butadiene styrene, that's a polymer, polycarbonate, nylon in their body, and polymethyl methacrylate, that is PMMA, in the display of the material. We use paper and book, that is made of carboxylated styrene butadiene latex in the glossy part, or styrene acrylic copolymers. Those are polymers. We use banknote, in which polypropylene is used. We also use in our day-to-day life chair, tables in office or at home, which is made of polypropylene, polyvinyl chloride. In bedroom, we use pillow or blanket made of polyurethane or polyester. Moreover, our dresses are made of cellulose, nylon, polyurethane, polyester, rayon, silk, all are polymers. So from the above few examples, we can say we are with polymer from morning to night, from toilet to bedroom. But what is the origin of polymer? Actually, polymer have existed naturally since life began. For example, DNA, RNA, proteins, polysaccharides are often called polymers, and those play crucial roles in plant and animal life. Now we will know a short history of polymer or polymer industry. Although the use of natural rubber as a natural polymer started in Aztec Empire, that is in Mesoamerican civilization, but up to 19th century, the polymer industry based on natural polymer and modification of natural polymer. For example, in 1820, Thomas Hancock observed that natural rubber could be fluid by applying shear stress. Between 1839 to 1851, Goodyear brothers heated natural rubber with sulfur to make vulcanized natural rubber with good elasticity and mechanical property. In 1888, John Dunlop invented tires. Bakelite by Leo Baekeland in 1910 was the first fully synthetic and commercialized polymer. But what is a polymer? The word polymer is derived from Greek words poly and meros. Poly mean many and meros mean parts. So you can say a molecule have many parts is known as polymer. Some scientists prefer to use the word macromolecule or large molecule instead of polymer. For example, polyethylene here is a polymer which is made from ethylene molecule. Another example is nylon 6,6, which is a synthetic polymer made from adipic acid and hexamethylene diamine. One can say a polymer is a substance composed of molecules that have long sequences of atoms or group of atoms linked to each other by primarily covalent bonds. A polymer is a substance composed of molecules that have long sequences of atoms or groups of atoms linked to each other by primarily covalent bond. Some scientists say that repeating unit of a monomer is a polymer. Repeating unit of a monomer is a polymer. When a polymer is formed by one kind of monomer, for example here polyethylene, we can use this simple definition. But think about when a polymer is formed from two monomers. For example, nylon 6,6 is a copolymer of adipic acid and hexamethylene diamine formed by condensation reaction. We could say the polymer is a substance having repeating constitutional or structural unit. A polymer will have a repeating building block. In here, constitutional or structural unit is the building block of the polymers. So when a polymer will be formed by two monomers or more monomers, we can use this kind of definition. A polymer is a substance having repeating constitutional or structural unit. Repeating constitutional or structural unit. But you know, before 1920, polymer was considered as physically associated aggregates. Before 1920, the polymer was considered as physically associated aggregates. In 1920, German scientist Hermann Staudinger said polymers comprise large molecules containing long sequences of simple units linked together by covalent bond. Who said? German scientist Hermann Staudinger in 1920. He said polymers comprise large molecules containing long sequences of simple units linked together by covalent bond. In 1920, Staudinger proved the linear structures of polyoxymethylene and polystyrene. X-ray studies of many natural and synthetic materials were used as structural proof that polymer existed. Staudinger introduced the word macromolecule to describe polymers. So he first used the word macromolecule to describe polymers. Although the words polymer and macromolecule are used interchangeably sometimes, but they are not the same. There is a fundamental difference between macromolecule and polymer. Macro is a prefix from Greek language meaning large or excess. We can say macromolecules are large molecules having large size and high molecular weight, whereas polymers also have large size and high molecular weight. But remember, they should consist of repeating molecules. They should have repeating molecules in their chemical structure. Macromolecules can form polymer. Macromolecules can form polymers if macromolecules are repeated in their chemical structure. if macromolecules are repeated in their chemical structure. So we can say that all polymers are macromolecules, but all macromolecules are not polymers, because macromolecules have large size, have high molecular weight. Polymers also have large size and high molecular weight, but all macromolecules are not polymers. They will be polymer only when the molecules are repeated in their chemical structure. It will be very clear if you see the example of lignin. Lignin is a complex organic material. It is a crucial structural material of plants. Lignins are cross-linked polyphenolic substrates where different bonds connect phenol derivatives. No repeating molecules exist in lignin structure. So we can say it is a macromolecule. It is not a polymer. Now we will know a few terms associated with the topic. For example, monomer. What is monomer? What is polymerization? What is degree of polymerization? The repeating unit by which a polymer or macromolecule is formed is called monomer. So what is monomer? The repeating unit by which a polymer or macromolecule is formed is called monomer. If we see the example, polyethylene is formed by ethylene molecule. And in polyethylene structure, if you see, the polyethylene consists of repeating unit of ethylene molecule. So ethylene is a monomer here. Now we will see what is a polymerization method or what is a polymerization. The process through which monomers link together by covalent bonds and form a polymer is known as polymerization. The process through which monomers link together by covalent bonds and form a polymer is known as polymerization or polymerization method or polymerization process. For example, polymer can be formed through free radical polymerization process. It could be formed by condensation polymerization process. So free radical polymerization, condensation polymerization can give polymer, can form polymer. Now we will know about the degree of polymerization. Number of repeating units in a polymer is known as degree of polymerization. In the structure of polyethylene, you can see N here. So N here, in the structure of polyethylene, you can see N here. So N here is the degree of polymerization. N indicates that N number of repeating units of ethylene can form polymers, polyethylene. So N is the degree of polymerization here. Remember, monomers, that is the ethylene, must have a functionality of 2 or higher to form polymer. As I have said, monomers must have functionality of 2 or higher. But what is functionality? The most basic requirement for polymerization is that each molecule of monomer must be capable of being linked to two or more other monomers by chemical reaction. That is, monomers must have a functionality of 2 or higher. The most basic requirement for polymerization is that each monomer molecule must be capable of being linked to two other molecules of monomer by chemical reaction. That is, monomers must have a functionality of 2 or higher. We can say functionality of a monomer is defined as the number of chain links it can give rise to. Number of chain links it can form through a polymerization reaction. It doesn't necessarily equal the number of functional groups in the monomer. Remember, it doesn't necessarily equal the number of functional groups in the monomer. It defines the number of chain links it can form through a polymerization reaction. Polymers formed by chain polymerization. For example, here you can see ethylene can form polyethylene molecule. Ethylene contains carbon-carbon double bond. These monomers have functionality 2 because this monomer can form 1 chain, 2 chain. It can form 1, 2 chains to form a polymerization. So you can say ethylene molecule has a functionality of 2. If monomer have functionality more than 2 or greater than 2, what will happen? From the picture it is very clear to you that when monomer will have functionality more than 2, they can form branch polymer or network polymer. They can form branch polymer or network polymer. When monomer will have functionality 2, they can form linear polymer. They can form linear polymer. Now we will discuss nomenclature of polymer. The naming of polymers is a complicated area. In that sense, most of polymers have more than one correct name. And the condition is more complicated when we see the variety of trade names used to describe certain polymers. They can be given names based on the place of origin of the material. For example, natural rubber. Natural rubber is called Hevia brasiliensis, meaning rubber from Brazil. They can be given names according to number of carbons in the reactants. For example, if you see the synthetic polymer nylon 6,6, the number 6 came from the number of carbons present in hexamethylene diamine compound. Now, another 6 came from number of carbon present in adipic acid compound. They can be given names from their discoverer. For example, bakelite is discovered by Leo Baekeland. Bakelite is discovered by Leo Baekeland. Few polymers also have trade names. For example, polyesters. Polyester has trade name Dacron. Polyesters has trade name Dacron. Many polymers are known by their family name. The family names from the characteristic linkage that connect monomer molecule. When you will give a name to a polymer based on the linkage present in the polymer molecule. The family name will be poly followed by the linkage. For example, if polymers contain repeating unit which have CH2 single bond CH2 unit, you can say the compound is polyvinyl compound. If repeating unit contain amide bond, we can say polyamide compound. If repeating units contain polyester bond, we can say polyester compound. If repeating units contain NH double bond OO bond, then we can say polyurethane compound. If repeating unit contains ester ether bond, we can say the polyether compound. If it contains anhydride units, we can say polyanhydride. Similarly, polyurea, polycarbonate, polysiloxane, if OSI unit is there. If the repeating unit is S sulfur compound, we can say polysulfide polymers. According to IUPAC rule, the polymer can be given name by two ways. One is source-based name, another is structure-based name. What is source-based name? It is based on the common name of monomer preceded by the prefix poly. For example, here, if you see monomer here, ethylene, and polymer, the name of the polymer will be polyethylene. It is a very simple method. We can use the common name of monomer preceded by the word poly here. Similarly, if you see the structure here, this is pent-guanine. Pent-guanine, or you can say pentene. So pentene is a monomer. When it will form polymer, we can say this is polypentene. So polypentene is the source-based name of the polymer. Similarly, polyethylene is the source-based name of polyethylene compound according to IUPAC. The source-based name is the very common name of a polymer. It is easy to understand and is widely used in the literature. If a polymer is formed by two monomers, we all know that the polymer is called copolymer. Copolymer also can be given name according to source-based name. For example, if a copolymer is formed by monomer A and B, we can use the general format like that: poly, first bracket, the first monomer hyphen co hyphen B, the second monomer, and close the first bracket. Okay, it will be very clear if you see the example here, the left hand side example. This is a copolymer of styrene and methyl methacrylate. So we can use poly, first bracket, styrene hyphen co hyphen methyl methacrylate for this copolymer. So you can give name to a copolymer like that: poly, start a first bracket, write down the name of the first monomer, hyphen co hyphen the second monomer. Similarly, if a copolymer is formed by two monomers or more than two monomers, by forming basically a block, then we can say that is block copolymer, right? So block polymers is basically copolymer, can be formed by two or more than two monomers. So on that case, we can give them name to block copolymer according to source-based name. The format will be poly, then the name of the first monomer, hyphen, block, hyphen, the second block, then hyphen, block, hyphen, the third monomer. For example, here, this is one example of a block copolymer, the right hand side, right? It is made from polystyrene. It is made from polystyrene block, polybutadiene block, and polystyrene block. Basically, this block copolymer is prepared by polymerization reaction of styrene 1,3-butadiene molecules. 1,3-butadiene molecules. So from the structure, we can see 3 blocks are present. We can give them name like polystyrene, the first block, hyphen, word block, hyphen, polybutadiene, the middle one, then block, hyphen, then the third block of the polymers. So that's all from today. Next day, we will talk about the structure-based name of polymer, molecular weight of the polymers, and their significance. We will also talk about classification of polymer materials. Thank you.